Here's the translated text without timestamps. You already know what happens when a gunshot hits the head. Death is the obvious outcome. A gunshot to the head is a fatal wound. But if we examine it in detail, we find that a lot happens when a bullet pierces the skull. First, let's clarify. We're talking exclusively about pistols and rifles, not shotguns, because a shotgun blast to the head doesn't require detailed analysis. So let's begin. When a rifle or pistol is fired, the bullet first travels down the barrel. A rifle barrel has rifling inside, which makes the bullet spin. When a spinning bullet penetrates the skull, its rotation stretches the skin up to 12.5 times the bullet's diameter. This lasts about 50 milliseconds before the tissue snaps back to its normal size. For example, a .22 caliber bullet creates a wound about 5 centimeters in diameter. A .38 caliber bullet produces a wound about 10.1 millimeters wide. A .45 caliber bullet leaves a hole roughly 12.7 millimeters in diameter. Additionally, such a wound causes significant damage to the skull itself. It creates a vacuum effect, sucking air into the cavity and causing the skull to expand, leading to cracks radiating from the bullet hole. Most cracks follow weak points, such as the temples and orbital bones. The stronger the shot, the more cracks spread across the skull, even through thicker, sturdier areas in the front and back. Now, what factor has the greatest impact on bodily damage? Bullet weight, length, or velocity? The correct answer is velocity. To understand why, let's look at the kinetic energy equation. In this case, a bullet's kinetic energy equals its weight multiplied by velocity squared, divided by twice the gravitational constant. If that sounds confusing, here's a simplified version. If weight equals 10, velocity equals 10, and gravitational constant equals 10, then kinetic energy equals 50. Doubling the bullet's weight doubles the kinetic energy. Doubling the velocity quadruples the kinetic energy. Higher kinetic energy means more damage, greater pressure waves, more gas entering the skull, more fractures, and even potential splitting. That's why rifles are deadlier than pistols, not because of bullet weight, but because of speed. Now let's see what happens inside the skull. When a bullet enters, it creates an entry hole roughly the bullet's size. Upon exit, it leaves a much larger hole. This happens with almost any material, wood, metal, plastic, or bone, because the bullet generates a shock wave ahead of it, expanding as it travels. The bullet may also fragment or deform, increasing the damage area. Inside the skull, the bullet leaves beveled edges around the hole. Imagine a piece of cheese. The entry side has a neat, small hole, while the exit side widens gradually. This is due to skull fragments breaking off and penetrating the brain, causing even more damage. A bullet in the brain faces three likely scenarios. 1. It slows and stops if it loses enough energy after penetrating the skull. 2. It exits cleanly. 3. It ricochets inside the head. The third scenario is the least probable, with only about a 20% chance. A powerful rifle shot will likely pass through, while a pistol bullet is more likely to stop inside or ricochet. Fun fact, most skull ricochets don't involve the bullet bouncing at an angle. Instead, the bullet often travels along the skull's interior, losing energy and sometimes lodging just beneath the bone. Finally, what happens to the brain during all this? Well, nothing good. The brain is a soft, inelastic organ, and these traits don't help it withstand gunshot damage. Elastic organs like the intestines, stomach, and bladder suffer less because their tissues stretch, dissipating energy. But solid organs, liver, pancreas, kidneys, heart, and brain, absorb the full impact because they don't stretch. Distance also plays a role. At long range, a bullet might just bounce off the skull, causing trauma comparable to a bat or hammer strike. But without penetration, assuming a weak pistol and a shot from over a kilometer away. Conversely, a point-blank shot turns the brain into mush for two reasons. 1. The bullet has maximum velocity and energy upon impact. 2. Hot gases follow the bullet into the wound, spreading and liquefying the brain. In some cases, such a shot can even split the skull. Believe it or not, a headshot isn't always 100% fatal, but that's a topic for another video, where I could explain how and why some people survive head wounds. If you're interested, Let me know by liking, commenting, and subscribing. It's the best way to support the channel. You can also contribute financially via Boost, links in the pinned comment and description. See you in the next video.